Now here we're just going to play, or I'm going to play a little, somewhat of a little game, more of a little exercise. We're going to observe the simulator and identify the forces present. And then after I show you it, I just want you can either draw the same thing that I'm about to show you, or come up with your own example. And to make to get the point across of this example, I want you to focus on the length of the arrows and the direction of the arrows, okay? So I'll share my desktop and we'll go here. So you can see my screen?
Yeah.
Perfect. Okay, so here we've got a man and we've got a box on top of a skateboard. And if you see, if I increase the amount of force, the arrow grows and the box starts to move at a certain speed. And then if I crank it up, the arrow becomes very big, and then the box becomes very fast, so fast that I can't keep up with it anymore. And then if I just restart this, I can also do it in the other way. So if I push it from the other direction, it's going to do the same thing. That arrow is going to get bigger the more force I put on it. And then as soon as I let go of it,
Oh,
it goes flying.
so yeah, it must have a point of like stopping because there's friction, right? So it can't just roll around forever. That
You're
there's
very
no
right. You're very right. So I'll go back to it actually, and I'll just apply a little bit of force so that it starts to go, and then I'll realize, or
um,
I'll release, and then you can see, yep, the friction does work on the skateboard's wheels, and then after a certain amount of time, it'll slow down. This surface is fairly smooth, so you can see it takes quite a little bit for it to slow down, but it will eventually. That was a good observation.
okay.
I'll give you a trophy for that. Good job.